This recording is going to consider the thing called a Venn diagram. Some of you may have encountered Venn diagrams both in the subject guide and in your textbooks, and Venn diagrams can often be a useful way to illustrate what's going on in terms of a probability problem. So I'm going to consider the following scenario. I have a class of 35 students. So there are 35 students in this class. I'm going to consider three particular disciplines which they may be studying. We have economics, and let's assume that 20 students are studying economics, and I'm going to denote economics by the letter E. History, and there, let's say, are 15 students studying history, and again history will be denoted hereafter by H. And politics, and assume there are 10 students studying politics, and yes, you've guessed it, we'll denote that by the letter P. Right, of course some students might be studying more than one of these disciplines, so let's assume that in terms of economics and history there are 9 students. There are 5 students who study economics and politics, 6 students who study history and politics, and 3 clever students who are studying all 3 subjects, economics, history and politics. So notice the use of this intersect notation. So the English equivalent is the word and. Okay, whereas so think of the intersect is equal to and, whereas the union intersect you can think of as being or. Okay, let's draw a nice Venn diagram. So we have 3 disciplines: economics, history and politics. So I'm going to denote these by 3 circles. Here's my economics circle, here's my history circle, and here's my politics circle, so E, H and P. Notice that these circles are overlapping because, notice I do have some intersections, namely the overlapping areas denote students studying more than one of the disciplines. Right, so what I want to do is to work out how many students are located in each particular segment of this Venn diagram. So I'm going to work backwards through the information I've got. So I'm going to work up in this direction. So first of all, I know that there are 3 students who study economics, history and politics. Where does this go in my Venn diagram? Well, this I'm going to put in here. So the number 3 goes in here, because in that particular section, okay, so just to illustrate, in this section here, that's the only area of the Venn diagram where all 3 circles overlap. Okay, so those 3 denote the students who study all 3 disciplines of economics, history and politics. Right, let's consider we have 6 students who study both history and politics. Well, where do students study history and politics? Well, what I'm going to do, let's just write the number in. The number 3 is going to go in here. So we have 2 lots of 3, so 3 plus 3 gives me 6, and these denote the 6 students who study history and politics. It just happens to be that 3 of these 6 students study economics as well. Using a similar logic, we have 5 students who study economics and politics. So what I'm going to do is write the number 2 in here, okay, because, let's just pick another colour, let's go for black. This 2 plus this 3 here denote the 5 students who study economics and politics. Again, it's because 3 of these 5 students study all 3 disciplines. However, there are 2 of the 5 students who just study economics and politics and not history. Similarly, we have 9 students who study economics and history. Clearly 3 of them study politics as well. So we have 6 goes in here because there are 6 of the 6 of these 9 students here do not study politics as well. In total there are 10 students of politics. I've accounted for how many so far? Well, I've accounted for 8, namely the following: this 2, this 3, and this 3, so I've accounted for 8 of them. So clearly there must be an additional 2 students who study politics but do not study either economics or history. In a similar way, we have 15 history students, so hopefully you can see that a 3 should go in here. So I've already accounted for 12 of these 15 history students. And finally, there are 20 economics students in total. I've accounted for 11 of them, and so we will have 9 go in here. But remember, how many students are in the class in total? Well, there are 35 students in the class. How many students have I accounted for so far in terms of economics, history, or politics? Well, if you add up all the numbers in this Venn diagram, you should come up with a total of 28, and so therefore there will be 7 students in the class who do not study economics, history, or politics. They study some other disciplines. Okay, so we've constructed our Venn diagram, and having done that, we can then answer any probability questions we choose. So, for example, what is the probability that at least, so if I pick a student from this class randomly, what is the probability that this student studies at least one of economics, history, or politics? Well, because that considers lots of different possibilities, it's either just economics, just history, just politics, or some combination of 2 or all 3 subjects. That could take a little while to work out, but clearly the probability of studying at least one subject is going to be 1 minus the probability of studying none of those 3 subjects. So 1 minus the probability of none. Because clearly a randomly selected student either studies none of economics, history, or politics, or studies at least one of them. And why is this an easier method to work with? Well, what is the probability of picking a student who studies none of economics, history, and politics? Well, out of the 35 students in the class, there are 7 who study none of economics, history, or politics. So this will just be 1 minus 7 over 35, which is equal to 28 over 35. Clearly, you could have obtained the 28 over 35 by adding up all the numbers within the economics, history, and politics circles, and again, that will add up to 28. So you can do it in using either method. You will get the same answer. So very often in probability questions, there can be more than one way of obtaining the same answer. So it's just that one method might be quicker to compute than another. But really it's just a question of practicing these sorts of questions. Then you should develop the intuition for knowing which should be the quicker approach. So here we've looked at constructing the Venn diagram, and if it helps you visualize what's going on, then by all means use it.